In this video, we're going to have a look at the 2017 National 5 Maths Paper 2 paper. We are not going to go through the questions as such. We're just going to have a quick walk through the paper, identify the kind of questions that are being asked, and then ask, I suppose, is this a fair paper? And are these fair questions? Because some people seem to think that it's not fair, that it was too hard, but just like with paper 1, I think the questions are exactly what they ought to be. They're quite clear in terms of what you're being asked to do. There's nothing particularly awkward or difficult as such, and the paper overall is fair and where it needs to be. So, as I was saying in the other video, the main problem people have is that they don't know how to get started with a question. So we'll just identify trigger words, phrases, things you should be noticing and picking up as you read these questions in order to set about forming and communicating your solution. Okay, so question 1, nice and straightforward. Find the magnitude of a vector. You've got your 3 components, so dead easy. Square them, add them together, square root it. You've got your calculator, so that should be no bother. Okay. Question 2, very common question. You have the necklace value increasing by 4.5% per year for 3 years. Find the value of the necklace at the end of that time. And the thing to pick up on that most people who maybe have read this question quickly will not is that you have to give your answer to the nearest pound. So all you have to do is just make sure you use a multiplier of 1.045, and you're going to do that to the power of 3, and you just multiply 1,200, excuse the 2, 1,200 by that multiplier, get your answer, give it to the nearest pound, and you've got that question done, I would say, in 20-30 seconds, and that's you with 3 marks in the bag. So far, nice and straightforward, nothing too awkward. You should be settling into the paper with your mind at ease that you've picked up some marks at least. Question 3, you've got a triangle in front of you, so you should be immediately thinking trigonometry. You're given 2 sides, and the angle in between. So what you've got is an angle sandwich, and you're asked to find the length of the fence that's going to be put along the side QR. So you want to find this side. You've got an angle sandwich. You've got all the ingredients you need to use the cosine rule. Look at your formula sheet, plug in the values, get the length of the fence, and that's 3 marks in the bag. Question 4, quadratic equation. You're told to give your answers to 1 decimal place, and that might as well scream out at you and say, use the quadratic formula. You've got the calculator, you've got the formula, put in the values. Be careful to note that A is going to be 2, B is going to be 5, and C is going to be -4. So pop these in, get your 2 solutions, and make sure you round them correctly. 3 marks in the bag. A theatre group sold a certain number of tickets. You're told that this is 15% more than they sold last year. How many did they sell last year? Again, common question, reverse percentage. You want to go back in time, think of the original amount as 100%. So what you're talking about is, at the moment, 115% of the tickets is going to be equal to 4,830. Find 1%, find 100%, 3 marks in the bag. There is nothing to complain about so far in this paper. Okay? So question 6, and you've got something similar to a Malteser. We've got a sweet covered in chocolate, a spherical sweet. And when you see the word sphere, you should be thinking, okay, formula sheet, volume of a sphere. The formula is there for me. It's just composite volume, so the coating is going to be the difference between the large sphere and the small sphere. The large sphere, if we call it sphere 1, it's going to have a radius of half of 24, which will be 12. The small sphere, if we take that away from it and that away from it. We're taking 6 away, so it's going to be 18. So the white bit is 18 millimeters wide. So half of that is 9. So we call that sphere 2. The radius of sphere 2 is going to be 9. So the radius of sphere 1 is 12. The radius of sphere 2 is 9. So just use the formula to work out the big sphere, use the formula to work out the small sphere, get your answer. 5 marks, nice and easy. Make sure for the final mark that you give your answer correct to 3 significant figures, because otherwise you're going to lose a mark. So formula sheet question, nothing awkward, composite volume, that should be 5 marks in the bag. You've got a lot going on in this question, but essentially as you read the text, what you're seeing is the triangle right-angled? And that should automatically trigger in your mind a response that says, okay, this is going to be a Converse of Pythagoras question. Now, what do I know about this big triangle? Well, I know that side is 8, I know this side is 19, and I know that the base of it is going to be the sum of 6 and 16, which is 24. And you know that the right angle, if it's anywhere, is going to be across from your supposed hypotenuse, if that's indeed what it is. So, Converse of Pythagoras, check the square of 24 against the sum of the square of 8 and 19. See if they are the same. If they are, because Pythagoras' theorem fits, you would say by the Converse of Pythagoras theorem, the triangle is right-angled. If they don't, if they're not identical, then you would say the opposite. And you make sure you mention by the Converse of Pythagoras theorem in your solution. Again, yes, there's a wee bit of a context to the question, a wee bit of a story as to what's going on, but nothing there that should throw you if you just pick up on that statement, is the triangle right-angled? You should know exactly what to do to prove whether or not that is the case. Question 8a is nice and easy. A vector journey, you're going from P to R, so you're taking the vector D and you're then going the opposite of vector C, so it's going to be D minus C. Okay, so D minus C would be your answer there. Part B is probably maybe the most tricky question in the paper, to be honest with you. You're told that V is the midpoint of PR, and you're also told that TP is PQ. So the journey from T to P is going to be exactly the same as the vector D, because we're told that TP is the same as PQ. Now, the thing to pick up on is that V is the midpoint of PR, and we're asked to find the journey from T to V. Now, we can't do it just by going directly, so we're going to have to take maybe what you would call the scenic route. So what we're going to do is we're going to go from T to P, and then we're going to go from P to R, okay, like so. And because we know that we don't want to go, well, if I can explain this just now, you want to go from P to V. Now the journey from P to V is going to be half of the journey that I've colored in green, because you know that V is the midpoint of PR. So what you should really say is that TV is going to be equal to TP plus the half of the journey from P to R. Now you've already got the journey from P to R. You've done that in part A. So you just say, well, TP is D, and then you're adding to that half of your answer to part A. So that was D minus C. You tidy it up and you get 2 marks. It's a wee bit tricky, but it's only worth 2 marks. So if you don't get it, it's not the end of the world. Okay? Nice and easy factorizing. No common factor. Difference of 2 squares. 1 mark. Got it. Now see this word hence. That basically says using what you have just done. Now, although the question in question 8 didn't use the word hence, we still needed to use our answer to part A to help us do part B. So you should always expect when a question is broken down like that, to perhaps have to use the answer to the previous part of the question in the next part of the question. So there you see that what you have just factorized appears as the numerator in this algebraic fraction. So you factorize the top again, put down your answer to part A, factorize the bottom, and you should find that factors cancel out, and you end up with a simplified version of what you're faced with in question 9b. Question 10, you've got three towns, we'll call them D, E, and F. You're asked to find the distance between Dunbridge and Fairtown, so we call that X. Key information, Dunbridge is west of Ellsford, so this line here is dead horizontal. So you can easily work out that this is going to be 40 degrees, okay? And because you know that's 90, because from north to this line going from west to east is going to be 90, you can see that that's going to be there 36, okay? Now that you know these two angles, you can then use the fact that they all add up to 180 to get this one. So this gives you a sum of 76, so this must be 104. And once you've done that, it's dead easy. So again, it's all about getting started. Ask yourself, what do I know? What can I do? What additional information can I add to my sketch? And there you have a question involving two pairs of opposites. So it's a nice, easy, straightforward sign rule question. 4 marks. Again, it's all about knowing how to get started. So pick up on keywords like west, and then you can actually get on with the question. If you don't pick up on that, you're not going to get anywhere. And again, it's a question that pretty much everybody would have been able to do had they been given a wee head start. Find the gradient of the line. All you have to do is rearrange it into the form y equals mx plus c, and just read the m value off. So 2 marks, nice and easy. That shouldn't be a problem. If you know your Indices rules, this should not be a major problem. You know that the cube root of x is x to the power of 1/3. So you've got your base on power on the bottom. All you have to do is take that base on power, move it upstairs. As you do that, the power is going to change, so you end up with x to the power of negative 1/3. Anybody who knows Indices rules will have that question done in 20 seconds. This question would have probably caught a few of you out, but if you just identify that the shapes are identical and you're asked to find the height of the logo, there's no information on the sketch, so you've got to pick up the information and annotate the sketch yourself. You're told the radius is 14 centimeters, and you're told that the line AB is 48 centimeters long, and your job is to find the height. Okay. Now, because the shapes are identical, if we can work out the length or the height of one of the shapes, then all we have to do is double our answer. Okay. So all you have to do is add to the sketch the information that you have picked up so far. Now we know that AB is 48 centimeters long. So from there to there is 48. So from here to the center of our logo is going to be 24. And from here to a point below C is going to be 12. Okay? You know the radius is 14. So all I have to do is form a right angle triangle. I can find the shorter side, which will give me the distance from the center of that circle to the line AB. And I know that the distance from the center to the top is a radius, so that's going to be 14. So once you do Pythagoras and work out x, and you add 14 to it, you found the length of that red line. Then all you have to do to find the height of the logo is double your answer, and that's you. Now, if you're totally stuck, it's the kind of question where you can maybe make something up and run with it and show the examiner that you would be able to find the height of the logo had you been able to maybe figure a certain thing out. So if in doubt, if there's some sort of stumbling block you can't get over and time is running out, just make something up, run with it, demonstrate to the examiner what knowledge you have, what skills you possess, and you may well pick up some follow-through marks. Question 14, you're asked to look at an arc. You're told the arc length is 31.5, so the distance from A all the way around is going to be 31.5. It's not the easiest arc length question because you're having to work backwards, but if you know that the arc length is the angle over 360 times pi d, and you use double the radius for your diameter, so it'll be 12.8, you just plug in the values, rearrange it, and there's nothing there that anybody's prepared for their exam should not be able to deal with. So again, 3 marks that should be easily accessible by the majority of candidates. Question 15, a lot of people didn't like it, and I think it's just because of the context and the story that's behind the question more than anything else. All you really need to focus on once you've read the story is that you have a tip. The tip of the blade follows this equation. And you're told that h is the height of the blade above the ground, and that x is the angle as the blade turns clockwise from its vertical position. Find the height of the tip of the blade after it's turned through an angle of 60 degrees. All you do is say that x is 60, because you're told that x is the angle. So you just say the height is 40 plus 23 cos of 60. You've got your calculator, and that will give you the answer straight away, 1 mark. That itself tells you how much effort it should take. With the same question, you're then asked to find the minimum height of the tip of the blade. Again, 1 mark. So it's not the kind of question you're going to spend 15 minutes on, unless you've got time at the end. The height is going to be 40 plus something. So the height is going to be at a minimum when whatever you're adding on is at a minimum. And what we're adding on itself is at a minimum when cos x is at a minimum, because 23 doesn't change. How small can cos x get? The smallest it can be is -1. So the smallest what's in the purple box can be is -23. So the smallest the height can be is 40 add -23, which is 17. So that's your answer. And finally, the values of x, notice that they're wanting 2 answers at least. The values for x for which the tip of the blade is 61 meters above the ground, well, this time you're told the height, and you have to work out x. So you just start off by saying, well, 61 is equal to 40 plus 23 cross x, excuse the writing. Rearrange that and take 40 away from both sides and divide everything by 23, and you end up with cos of x is equal to, and so we're going to end up with 21 over 23. So you've got a trig equation, cos of x is equal to 21 over 23. Do your cast diagram, identify your solutions, and there's nothing there that should cause anybody any bother. Once you have started that, subbed in the values, rearranged it to get cos of x is 21 over 23, straightforward trig equation, you're working between 0 and 360, 4 marks that should be accessible. Don't let the context of the question put you off. The story should not detract from the fact that you've just been given a trig equation and you've been asked to sub in a value for it and then go on and solve it. So overall, paper, I would say, is pretty fair. It tests you on the course content. The level is where it needs to be, and there is no reason for anybody to be putting their name to a petition asking for the SQA to lower the pass mark. If you have not passed the exam, then you have to yourself decide why that was the case. If you didn't perform well on the exam, if you couldn't tackle the questions, you have to ask yourself, well, why was that the case? These questions have been, variations of these questions have been seen in past papers down through the years. Anybody who's worked through past papers under exam conditions, there should be no reason why they couldn't deal with this kind of paper. So I hope that was helpful. It's just a quick overview of the paper. and in my mind it's a good paper and there shouldn't be any complaints. So I hope that was helpful, and we'll leave it there for just now.